And I think actually what I gave you in the problem was not just 8%, but I said 8.00. Okay, 8.00% calcium chloride. So you can figure out any values, measurement values for calcium chloride, for a calcium chloride solution that gives you 8%. The easy one maybe is 8.00 grams of calcium chloride over 100 grams of solution. Or you could do 0.08 grams of calcium chloride over 1 gram of calcium chloride solution. Either one of those would be a perfectly good representation of 8% that would be more practical for you to work with. Most people use this. Is that what you guys started with? Okay, well let's start with that then. So we're going to say 8.00 grams of calcium chloride in 100 grams of calcium chloride solution. We exchange. You already exchanged papers. Okay. And to get the molality, excuse me, of the solution, that's what we're looking for, molality or molal concentration. We need to be able to get our solution into moles of solute. In this case, solute is calcium chloride over liters of solution, and the solution here is calcium chloride solution. Okay. I'm sorry, we're not looking for molarity. We're looking for molality, aren't we? This is kilograms of solvent. And the solvent is not calcium chloride, but water. Okay, I had it up there for molarity. My other class, we're still working with molarities a lot right now. So we're looking for moles of solute over kilograms of solvent, and the solvent is H2O. So since this is the solution, and the solution is made of both the solute and solvent, we need to be able to get rid of the solute from this number here in order to find just the solvent. And the solute we already have. It's 8 grams of this stuff. Okay? This is the solute is the stuff being dissolved. Calcium chloride is being dissolved in water. So before we can even solve the problem, we need to take 100 grams of the calcium chloride solution. We need to subtract from that 8 grams of just the calcium chloride, and we get 92.00 grams of water. Whenever you have a solution that goes by just what the solute is, that is named just for the solute, you always assume, and it's reasonable to assume because that's what it's supposed to be, you always assume the solvent to be water. So we need to start with not 8 grams over 100 grams of solution, but 8 grams of calcium chloride over 92 grams of water, because we want to get solvent, not solution on the bottom when we're done. You got that? Is everybody with me? Okay. So 8.00 grams of calcium chloride over 92 grams of water. And now we can convert grams of calcium chloride into moles. That's what we need to have on the top, moles of the solute. Well, for that then we need a molar mass calculation. So we need calcium and chlorine. Calcium's mass on your periodic table is 40.08. Chloride is 35.45. We have one of these and two of these. So 40.08, 70.90, 98, and this is 110.98 grams of calcium chloride in 1 mole of calcium chloride. So with this equality statement now, we can build a conversion unit. We need a conversion unit to get from moles to grams to moles. So we want to put the side of the equality statement that matches the starting units and species. Since we're working with what's on the top here, this is our starting amount for this part of the conversion. Put this on the bottom to be able to cancel grams and calcium chloride. We put 110.98 grams calcium chloride and 1 mole of calcium chloride on the top. What this does then is, because we have the same thing on the top and bottom, just like x's and y's in algebra, we can cancel those, and we successfully have gotten the top part into what we need, moles of calcium chloride. When we do the multiplication, we'll have that. We still need to get grams of the solute into kilograms, grams of the solvent into kilograms of the solvent. And for that, we just need a simple memorized ratio of 1,000 grams equals 1 kilogram. With this is an equality statement from which we built this conversion unit. This is an equality statement that allows us to build this conversion unit. We want the 1,000 grams to be on the top to cancel this number of grams here. And we want the 1 kilogram to be on the bottom, because when we're done, we want our solvent amount to be on the bottom here. Okay? And this will get our water, which is the solvent, on the bottom in kilograms. Allows us to cancel the grams. And we're ready to do the math. Okay, so in your calculator, if you don't have one of these kind of calculators, and some of you do, you just simply multiply everything across the top, hit enter, then divide by the things on the bottom in separate operations. So you divide by 92.00, hit enter, and then divide by 110.98, hit enter. Okay, so this will give us the answer we want here. And 0.735332,64905. And what we have left in terms of units are moles of calcium chloride. That's not what you got?
Oh, I got it, but I did it wrong apparently. So.
And on the bottom we have kilograms of water. You need to round it off to 3 digits, because the measured or calculated number with the least number of digits is this one. That 0 is not significant. 1, 2, 3. Underline them here over. And we're going to get 0.784 moles of solute over kilograms of solvent is molality. We can write a simple lowercase m, calcium chloride solution. Okay, so 8 grams calcium chloride, cancel. 92 grams of water, cancel, times 1 mole calcium chloride over 110 grams of calcium chloride, cancel, times 1,000 grams, cancel, over 1 kilogram equals, I'm waiting to make sure we're all understanding what's going on here. That's fine if you're trying to figure out what you messed up on. If you messed up on something or somebody else did, that's fine. So we'll make sure that everybody's, where they can pay attention though to what I'm explaining too. And then You don't really, if you recognize you got moles of solvent over kilograms of solvent, you don't have to write this. I'm not going to give any credit for this fraction. I like to write it there so I can make sure that I've got my units of measurement lined up properly before I round off. I won't give you credit for underlining the insignificant digits and the arrow. The correct answer, moles, calcium chloride in solution. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So this part of the calculation I'm giving 32 points. Let's see, somewhere along the way you've got to show that you either got to say or show that you subtracted, I don't know, that's pretty easy to do in your head. Let me think about that a minute. Now, really you should show your work, okay? You could do this in your head. I won't give you credit for having done that in your head, okay? But you need to show your work on a test or homework. Got it? Everybody understand? Yes.
Like, everything was right, but the answer and then the 8 was over, so I just not count credit for not having the 92 and not having the right answer. They had like this significant.
Well, they had something else besides 92?
I had 100. You don't have to, how are you going to assume that it's 100 grams starting solution?
You don't have to assume it's 100 grams. You can assume it's anything that gives you the right ratio for an 8% solution. You could use 0.08 over 1. That's an 8% solution.
But that's what I was talking about. Like, I thought that because it was 8% solution, like you put 8 over 100 times 1 mole over that. So like everything is right except for the answer and then the 100.
Because they didn't subtract the 8 grams.
Yeah, so I just not give them credit for not having the 92 and not having the right answer.
Yep. If I'm not going to count this today, then that's what you count off. You're correct. Okay? All right, you got to have a molar mass calculation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 points for that. You have to have a ratio here to show where you got your conversion for the 1,000 grams equals a kilogram. This fraction here, 1, 2, 3, 4, 5. So 32 plus 19, whoops, I hit a button wrong somewhere.
56.
Is it 56? Okay. Total 56 points? What in the world did I do there? Gracious alive. Okay.